Let's take a look at integrating some of the hyperbolic functions. Example 1, we're going to integrate than, and we want to show that it's equal to ln of cosh. So we think about than as sine over cosh. And clearly here we've got an integral with the derivative on top. So in terms of a show question, there's not really much to do here in terms of, apart from realise that cosh differentiates the sine, so the derivative is on top, and that would give us ln cosh x plus c. Not really an exam style question this, but like technically if you were going to show this, another way to do it is to use a substitution. You could say u equals cosh. So then du by dx would equal sine. So du over sine would equal dx. Like this would be a way to actually show where the answer comes from, because then you've got sine cosh, which is just u, dx, which is du over sine. So clearly we've shown that the answer now comes from this, because we obviously we're assuming this result here in the exam if this was asked to show, but like let's not get bogged down on it. Like we technically could also show it. A much more like rigorous way to show it is to actually do the substitution, because you see that the answer comes out, then we know that the integral of 1 over u is ln u. So that would be ln of cosh. Okay, next time we want to integrate cosh squared. Now obviously this is very similar to the normal maths style questions. Like if you want to integrate cos squared, don't integrate it. You want to be thinking about the cos 2 theta identity. But because we're working with the hyperbolics, you need to think about the hyperbolic version of this. Okay, so we should know cos 2 theta is equal to cosh squared theta plus sine squared theta. You actually get that in the formula booklet, so you don't need to remember this one. Cosh theta is cosh squared plus sine squared, and we also know that cosh minus sine squared is equal to 1. So combining these two identities together, we should be able to represent cosh squared in terms of cosh 2 theta. So sine squared would be cosh squared minus 1. So we know that cosh 2 theta is 2 cosh squared theta minus 1. Obviously you can just remember that identity, like if it's not like a show question, but I thought I'd show you where it comes from, just from these two identities that we should remember. So now if we're trying to integrate this, if we rearrange we know cosh squared is equal to cosh 2 theta plus 1, all divided by 2. So this integral would be the same as 1/2 of cosh 2x plus 1 with respect to x. Cosh integrates to sine. Just remember, sine goes to cosh, cosh goes to sine. You don't need to worry about plus or minus with the hyperbolic. Because it's 2x, we'll divide by 2 as we integrate. And then we need the constants, because we don't have any limits. Example 3 is definitely like an exam style question, so we'll have to read this one carefully. It says the region bound by the curve y equals sine, the x-axis, and the line x equals ln3 is rotated through 2 pi radians above the x-axis we want to show the volume generated looks like this. So just try and visualize what's going on here. The shine function looks like this. Now we're rotating it from 0. Now it doesn't say x equals 0, does it? But it says the region. Now, because we know it goes through the origin, so we're going from 0 to ln3. And this region here, between the x-axis and the curve, is rotated through 2 pi radians. So if we did rotate that all the way around, it would form a shape that looked like this. And we're aiming to find the volume as it's rotated all the way about the x-axis. Okay, so something we should remember from last year, the volume is equal to pi times the integral of y squared with respect to x. And that's our formula. If it's rotated about the x-axis, we square the function, and then we integrate with respect to x. So let's start by setting up our integral. We could get one more just for like setting up the actual integral itself. We're going to integrate from 0 to ln3. Y squared, which would be shine squared with respect to x. Now clearly this is quite like the example that we've just done. Like we're now at the point where we're trying to integrate shine squared. We've got to use cos 2 theta. So cos 2 theta we know is cos squared theta plus shine squared theta. We also know cos squared theta minus shine squared theta is equal to 1. So cos 2 theta would equal, we're trying to write it in terms of shine squared, so we could replace cos squared with 1 plus shine squared plus shine squared. Okay. In other words, cos 2x is the same as 1 plus 2 shine squared x, and this is going to allow us to rearrange to integrate. We could write it as cos 2x minus 1 all divided by 2, and that's going to be what we can integrate. Take the half outside, and then we're trying to integrate cos 2x minus 1 with respect to x. Cos integrates the shine, divide by the 2. Minus 1 becomes minus x. And the limits for this were ln 3 and 0. So all we've got to do now is sub in our limits and hopefully get to the answer that we were asked to provide. Okay. When we sub ln3 in, this is the bit that we've got to be careful of. Like we're subbing ln3 into this function. This is the bit that's going to take a little bit of care. So you may be able to do this on your calculator, but the fact that it's a show question, I'm going to show you where this comes from. Like shine, don't forget, shine of theta is e to the theta minus e to the minus theta, all divided by 2. So shine of 2x would be e of 2x, and in this case x is ln 3, minus e of minus x, which is 2 ln 3, all divided by 2. So that's what this looks like when we sub ln 3 into this part. Okay, we've also got to remember multiplying by a half and a pi over 2. Minus x, which would be minus ln 3, minus, oh god damn it, When we sub 0 in... Oh no, we're fine, we're fine. I'm talking nonsense, right? I thought we were subbing it, and I had a brain melt then for a second. So, we've got a sub 0 in. And subbing 0 into shine. And minus x, so it'll be minus 0. Now obviously if you think about what the shine graph looks like, we've already drawn that. If we work out shine as 0, we just get 0. So that would become 0, that would become 0. The only thing we've got to do now is just tidy this bit up, and hopefully we'll get to the answer that we were asked to provide. Okay, so we've got pi over 2, a half. So I'm going to write this as all divided by 4. And then think about how we're going to tidy this bit up. So we've got e of 2 ln 3. We know e and ln cancel each other out. That would become 3 squared. Minus. We also want the e and the ln to cancel out, but take the minus 2 up. So that would become 3 to the power minus 2. And then we've got minus ln 3. Okay, so let's tidy this up. We're aiming to get to this. We've got pi over 2. At this point we can probably reach for the calculator, can't we? But we've got 3 squared, which is 9, minus a ninth, all over 4, and minus ln 3. We're aiming to get pi over 18 and 20 here. If we group this together, thinking about this as ninths, and we've got 81 minus 1, so that would be 80 over 9 divided by 4. So that, if you do 80 over 9 and divide it by 4 as well, that's 20 over 9, which is where this 20 is going to come from. So we could write pi over 2, 20 over 9. And now at this point we need to think about the ln 3. We want 9/18. Okay. Let me actually just expand it out first, and it'll probably be easier. So we'd get, multiplying this out, that would become 20 over 18, and then minus a half ln 3. So we can think about this 1/2 as 9/18, which allows us to take the 18th back outside. As required. Let's try one last question. So this one we're going to do a substitution technique. We've got limits. It's told to use the substitution u equals cosh. Which it's a good job that we're being told this, because if you're looking at this I would probably be tempted to do shine, because I've got that shine cubed, but we're specifically told to let u equal cosh. This is not one that they would expect you to know what to do without being told the substitution, because you'll see what happens. It's not as obvious. You wouldn't be able to look down and say let u equal cosh. So let's start with the substitution that we've been given. U equals cosh x. So du by dx would equal shine. And then we want to replace this dx. So dx would equal du divided by shine. Let's sub into the integral and see what happens. So we've got shine cubed divided by cosh, which is u, plus 1, and dx we can write as du over shine. Tidying this up, we've got shine cubed divided by shine, which we can write as shine squared. But when this happens, we can't integrate this obviously until, like, the whole point of the substitution is we want to get rid of all the x terms, don't we? And we're left with this shine squared of x. And we're thinking, well, how am I going to replace shine squared? The substitution I know tells you about cosh, u equals cosh. So we've got to think of a way of like linking u, which is cosh, in terms of shine squared, which is what we're trying to replace. Clearly we're going to use an identity, aren't we? Like, this is hyperbolic, or any sort of trig involved, identity is going to be tested. We know cosh squared theta minus shine squared theta is equal to 1. So if we use this, cosh squared x minus 1 would equal shine squared x. So shine squared, we could write as cosh squared minus 1, which would be u squared minus 1. So now we've got an integral, we've replaced all the x terms, we've got to think now about how we can integrate this. It doesn't look like something I've integrated before, like it's a fraction, it's not going to become an ln. You've got to notice that we've got a difference of 2 squares on the top, like that's u plus 1, u minus 1, divided by u plus 1. So simplifying this down, we're integrating u minus 1. Okay, with respect to u, so that would become u squared over 2 minus u. And now obviously we've got to be careful, because we've got limits, we can change our limits. So I think the best way to do it, we could write it back in terms of x, but I think maybe changing the limits would be a bit neater on this one. So if x equals 0, u would equal cosh of 0, which would be 1. And if x equals ln 2, u would equal cosh of ln 2. So cosh of ln 2 would be e ln 2 plus e minus ln 2 all divided by 2. E of ln 2 is 2. Bring the minus up, so that becomes plus 2 to the minus 1, which is a half, all divided by 2. So we've got 5 over 2 divided by 2, so that would become 5 over 4. Okay, so sub in the limits. Top limit's 5 over 4. Bottom limit would become 1. And then we'd get 25 over 16 divided by 2. Which we should probably reach for the calculator, shouldn't we? But we're aiming to get the answer of 1 over 32. Okay, so we're nearly there without it. 25 over 32 minus 4 times that by 8 gives 32. So that would become 40 over 32. 16 over 32 plus 32 over 32. So we've got 25 minus 40 minus 15 minus 16 minus 31 plus 32. There we go, 1 over 32. Okay, thanks guys.